Good day to you. This is teacher Leland, Alejandro, and we're going to discuss today evaluating the 6 trigonometric functions. So this is under trigonometry. So we're going to see the problem set and we'll solve some trigonometric functions. So this will be the 6 trigonometric functions which involve sine, cosine, tangent, cosecant, secant, and cotangent. So we will try to solve some problems in the other screen. So let us see the worksheet. Okay, so this will be our worksheet, and we shall have about how many numbers? We shall have about 14. Yes, 14. All right, so let us start from the first one. We shall solve it using the presentation view. Okay, this is number 1. Find the required trigonometric function of angle theta for the following. This is number 1. Find the value of sine theta given that cotangent theta is equal to 5/12. Okay, I think we can solve this using just a simple right triangle. So let us draw a right triangle. Okay, let us have this right triangle. Let us put it in center. All right, let's put it as center. Okay, so let's put it down here. And let this be our right angle. This will be our theta. Okay, what we have is cotangent of theta, and this is the ratio of adjacent side to the opposite side. So if we consider theta here, the adjacent side is 5. And the opposite side must be the 12, okay? That gives us cotangent theta. Okay, so it's 5/12. And so we need to compute for the sine of theta, and this will involve the hypotenuse. So we will have to compute for the hypotenuse here. Okay, and so the hypotenuse will have to be computed using the Pythagorean Theorem, which is the square root of the legs, squares of the legs. Okay, the sun. All right, so this will be 5 squared plus 12 squared. This is 25 plus 144. And this will be equivalent to square root of 169. And this will be 13. Okay, so we have the value of the hypotenuse, which is 13. We are now ready to compute for the sine function. So the sine function is 12/13. Okay, that's opposite over hypotenuse. So our answer will be sine of theta. Sine of theta will be 12/13. There. Okay, let's check and verify the answer. Our answer is 12/13. So we shall check and verify. All right, so that's it. We have it over there. Let's have the second. Let's clear the screen and proceed to the second question. Here's the second. Given that cosine theta is 21/29, what is the value of sine of theta? Okay, for theta between 0 and 90. Again, we can just make a right triangle here, okay? We can just make a right triangle. So let's consider a right triangle like this with the 90 over here, and the theta must be the angle theta here, like that. Okay, so between 0 and 90, this will be an acute angle between 0 and 90. All right, we're after the sine of theta. What we have is the cosine of theta. Cosine is adjacent over hypotenuse. So if you will put the 21 and 29 in the figure, the 21 will occupy the adjacent there, and the 29 will occupy the hypotenuse there. Okay, so using the variables x, y, and r, let's use this 21 as our x, and our r is 29 there for hypotenuse. Now we will be using this for our y. Okay, the vertical side. All right, and so for sine theta, we will be using opposite side over hypotenuse, which is y over r. Okay, and so we need the y first. All right, so the formula for the y using Pythagorean theorem will be y is equal to the square root of r squared minus x squared, like this. So this is y is equal to r squared, this is 29 squared, minus x squared, this is 21 squared, like this. And so how much is 29 by 29? This will be, that's 8 there, and that's 26, and then 18, and 1, that'd be 5, 14, and that must be 841. So we have here 841 minus 21 squared is, that's 441, yes? That's 441 there. And so 841 minus 441, that's exactly 400. And we have the square root of 400, which is 20. And we have, this is y, and this is y. There. All right, so the value of y is 20. And we can now compute our sine theta. It's y over r. Okay, so our sine theta is y over r, that's 20 over 29. There. And so we shall verify, check the answer. Okay, it's 20 over 29 over here. And that's it. This goes to our number 2. Let's continue with the third number. Let's clear the screen, and we shall continue with the third. Okay, here's the third number. We're looking for an angle between 90 and 180, given that tangent theta is equal to negative 12 over 5. So this must be at the second quadrant, between 90 and 180. So we shall use a diagram here so that we will have a clearer picture of the answer. Let's have this our y and this our x-axis. Okay, and we shall put some labels x, and then this is our origin, this is our y. Okay, so let's draw a reference triangle like this. Okay, and let this be our theta, like that. Okay, all right, and so we're looking for negative 12 over 5 tangent, so that must be the 12 here and the 5 over here, and this must be negative, and this will be for y, this will be for x. And before we can have our cosine, we need the r, okay, for the hypotenuse. Okay, and we shall be able to compute that. So r is the hypotenuse. We can use this formula. R is equal to the square root of x squared plus y squared, and r is equal to the square root of negative 5 squared plus 12 squared, and this will be 25, and this will be 144. Under the square root, this will be square root of 169, and this will be 13. And that's it. R is equal to 13 there, and this will be 13. R is equal to 13 there. Okay, so this will be 13. Let me write clearly. All right, so we can now determine our cosine. This will be a negative cosine of the second quadrant, and that will be cosine of theta is x over r, and this will be negative 5 over 13. This will be our cosine of theta there. Okay, let's check the answer. We shall check the answer. All right, this is -5/13. And this goes to our number 3. Let's proceed to number 4. All right, let's continue with number 4. Here's number 4. Given that tangent theta is equal to 15/8, what is the value of cotangent theta? Angle theta is between 0 and 90. We can just draw a simple right triangle. After all, this is in the first quadrant and there are no negative values there. So we will just draw a simple right triangle like this. Or we shall put it at the left side, okay? Let's put it at the left side. So we will have more space to write on. You can put it over here. After all, these are all positive values. Now, if we put theta over here, we have tangent of theta, which is 15/8. Tangent involves the ratio of opposite side to the adjacent. Adjacent will be the 8, and opposite will be the 15. There. And we shall make use of the variables x and the variables r and y. Okay, this vertical will be y. Now, we're after cotangent theta only. This will not involve hypotenuse. So we don't need to solve for, we don't have to solve for the hypotenuse. We can get it from the x and y, okay? Now, cotangent theta will be just adjacent to the opposite side. So it's 8/15. Cotangent of theta will be x over y. And cotangent theta is equal to x, that's 8/15. So it's just a reciprocal, okay? After all, we know that from reciprocal function. So 15/8 is 8/15, okay? So I just did the full explanation of this using a triangle, okay? So the answer is 8/15, there. All right, so we can check and verify, there. It's 8/15, so this must be correct. All right, let's continue. Just remember, cotangent of theta is 1/tangent of theta, okay? There. Also, tangent of theta is 1/cotangent, okay? All right, whichever is given, you'll be able to get one of them. I would say if one is given, you can have both of the values. All right, so let's continue with number 5. Okay, here is number 5. Given that cosine theta is equal to 8/17, what is the value of tangent theta for angle theta between 270 and 360? Now, if the angle is between 270 and 360, this must be at the 4th quadrant. Okay, so we shall try to illustrate using the x and y axis. This is our y, and this must be our x. And this is our origin. Okay, now we're after tangent theta, and what we have is cosine theta. We can draw a reference triangle like this. Okay, and then this will consist of the variables x for the adjacent, and y for the opposite, and r for the hypotenuse, like that. Okay, since what we have a cosine of theta, and our theta is like this, okay, that angle theta, all right, we shall use the reference angle there, which is just the small angle here, okay? All right, now our given data is cosine, and it's a positive at the 4th quadrant, and this will involve 8/17 there, and those are the sides involved. So that is what we have. The cosine is the equivalent x/r, okay? Cosine of theta is x/r, and that is 8/17. There. These are given. We're after tangent of theta. We're looking for tangent of theta. There, okay? Our tangent of theta will be y over x, okay? So let's remove the question mark and let's make use of y over x. There, y over x. Now, we don't have the y, okay? So we shall solve for the y first, and we will have something like y is equal to the square root of r squared minus the x squared, like this. And so this is 17 squared minus x squared, that's 8 squared under the square root sign, okay? And 17 squared must be about 289. And then minus 8 squared, which is 64. And so we have something like, how much is this? This is 5, 2, and 2. Square root of 225 is 15. So our y is 15. There. And we have the required side, which is 15. We can now compute for our tangent. Now, this value is the value of y at the fourth quadrant. So this must be negative, okay? So this is a negative 15. Remember, the sign of the y there is negative. And so our tangent of theta is negative 15 over 8, okay? So it's negative 15 over 8 there, okay? All right, so that should be it. That's the sign of the tangent function at the fourth quadrant, okay? All right, and so let's check and verify the answer. There, it's negative 15 over 8. There. All right, number 6. Let's do number 6. Okay, here is number 6. Okay, we have a different instruction here, and we have a different given. Use the given point on the terminal side of angle theta to find the value of sine, to find the value of the trigonometric function indicated. Okay, so what we have here is a point on the terminal side. So for standard position angle, we have the initial side, which is coinciding with the right side of the x-axis. Okay, that's pointing east. All right, and then the terminal side may rotate clockwise or counterclockwise. Okay, so the terminal side has the point 3 and 4. Okay, so that means the x value there is the 3. Okay, the x value there is the 3, and the y value is the positive 4. So if we will redraw it, we shall have something like this one. All right, our value here is x equals 3, and we can take this our reference triangle. This must be our y, and this will be our x. This will be our 3, and this will be our 4. Remember, this is a point like that, okay? And this is 3, 4, like that. And this is actually the origin there, like this, okay? So I'm just trying to draw the reference triangle. And we need the r here. So we shall have the r, because the sine function uses the hypotenuse. So for a triangle with legs 3 and 4, the hypotenuse must be 5, okay? So r here is 5. Now, if you're not familiar with this triangle, this is actually like this. R squared r squared is equal to x squared plus y squared, like this. So this is r is equal to the square root of x squared, that's 3 squared, plus y squared, that's 4 squared, and r is equal to 9 plus 16. And then we add this will be a square root of 25, which is exact at 5 there. Okay, all right, and so we have now our explanation on how we got our 5. All right, but we will be needing the 5 for the sine. Okay, sine function. It's opposite over hypotenuse. So in our triangle here, the 3 is adjacent. Okay, considering our angle is our reference angle is this angle here. So for the sine function, it will be opposite uh, side to that angle. So that'll be 4/5. Okay, so our sine of theta will be 4/5 there. Okay, it's y over r. Okay, sine of theta is y over r. So that'll be 4/5. Okay, 4/5. Let us check and verify. It must be positive because it's at the first quadrant. Yeah. So the answer is the small fraction over here. There. Okay. Written by the computer near the diagram. Number 7. Let's try doing number 7. Okay, let's solve number 7. Okay, here is number 7's question. Use the given point on the terminal side of angle theta to find the value of the trigonometric function indicated. Again, this is a terminal side of the first quadrant, means the functions or the trigonometric functions are positive. And so we have our x there. The x is 3 and the y is 19. Okay. All right. And so we shall try to exaggerate the triangle or the reference triangle. So the triangle must look like this. Okay, we can make the figure larger. Okay, we can make the figure larger. Okay, all right, like that. And then we have this vertical side that will be representing y. Okay, and a small value there, horizontal, will be x. Okay, all right. Let me return it to the original. Let me just redraw it. Okay. All right, so let me just return it. Okay, if we shall exaggerate and redraw it and give it a little angle there, okay, and this is actually 3 and 19. This is 3 and 19. So x is 3. And the y is 19. Okay, like that. Now, we're after tangent of theta. For tangent, it will not involve the r. Okay, that will not involve the r. Okay, considering this our reference angle. Okay, if we consider this our reference angle, it will have to be just the opposite side to the adjacent side ratio. Okay, so this will have 19/3. Okay, the tangent of theta. Tangent theta is y over x. So our answer will be just 19/3. And that's it. Okay, and let's check and verify the answer. Is it 19/3? Yes, the answer is over here. There. Okay, all right. So this will be the formula. Okay, just take the vertical length as y and the horizontal length x, and the given points will be used there. Okay, if just in case the required function requires the hypotenuse, then you have to make use of the Pythagorean theorem and compute for the r. Okay, in this case, since tangent is the required function, it does not require the r. And if just in case you need the r, then use this formula. There. Okay, all right, so you have to use this formula just in case r is required. Let's proceed to number 8. So let me clear the screen and proceed to number 8. Okay, here's an angle of which the terminal side is at the third quadrant, and we're looking for cosine of theta. Cosine of theta. So our reference angle will be used there. Okay, our reference angle. Now, a reference angle is the angle which is the result of subtracting or getting the difference between the terminal side and the x-axis. Okay, so the angle made by the x-axis and the terminal side. So in this case, our reference angle is over here. This this is our reference angle. And so if we're going to draw our right triangle, if we shall attempt to draw our right triangle, it will be like this. There. And our reference angle is right here. This is our reference angle. Now, how about our x and y? Our x is actually, our xy point is right there. Okay. And so this is the -4, and the one with the radical -2 square root of 5, like that. So, of course, our x and y in the third quadrant are both negative. The x will be over here. And this is -4. And that will be for our adjacent side. The y will be for our opposite side. And that is -2 square root of 5, like that. Okay. All right. And this is our right angle, of course. This is our right angle, like that. Now, the required function is cosine. So we will have to find our hypotenuse r. There, we have to find our hypotenuse r. So we will have to make use of the formula a while ago. That would be r is equal to square root of x squared plus y squared, like that. Okay. Now we shall use our x and y here. So r is equal to x squared. That's -4 squared plus y squared. This is -2 square root of 5 squared. There. And so we have r is equal to the square root of 16. That becomes +16. And this will be squaring the 2 is 4. Squaring the square root of 5, that would be 5. So we will have 5 times 4, which is just 20. There. And r is square root of 36. And r is 6. There. Okay. R is always computed, always positive. Okay. So this will be a value 6. Now, we're ready to compute our cosine. And this will be involving the x and the r. Okay. Because our x is our adjacent side to this angle. Okay. And our y is the opposite side. And cosine will not involve the opposite side. So our cosine will be x over r. Okay, so our cosine theta will be x over r. And the cosine at the third quadrant is negative. Okay, so this will be equivalent to -4 divided by our r, which is 6. Now, if we reduce this to lowest term, this will be a -2/3. Okay, canceling out the 2. So this will be -2/3. So cosine of theta is -2/3. There. Okay, and that's it. That should be our answer. -2/3. Let us verify. It's a negative value. There, it's a -2/3. There. So we're the same with the computer. So that's it. We're correct at -2/3. Let's continue with number 9. Let me clear the screen and then continue with the next diagram. Here's number 9. Another point at the third quadrant, and this time it's sine theta. Use the given point on the terminal side of angle theta to find the value of the trigonometric function sine theta. Okay, the given here is -6, -8. So our reference triangle is similar to the one we had a while ago. Okay, so imagine our triangle. It will be something like this. There. And x value is the -6. The y value is the -8. There. And the r, if we need r, then we have to compute, and it will be this. Okay. And we don't have that yet. Now, this is actually the given point in the diagram. And again, our reference angle is defined, which is the difference between the terminal side and the x-axis. So in our diagram, it will be here. This is our reference angle there. And so we will have to take the x, our adjacent. We will take the y as our opposite side, considering this angle here. And so r is our hypotenuse, which is not given. Now, if you will solve for r, that should be 10, okay? That should be 10, okay? And I will show you why it's 10. So this is the formula, the Pythagorean theorem formula. And x will be 6 negative squared, and y is -8 squared. There. And this will be both under the square root sign. This gives us 36. This gives us 64. And the sum of this under the square root is square root of 100. And square root of 100 is exactly 10. That's why we have r equal to 10. Now, we need r for the sine function. Sine function will involve the y, which is the opposite side. Opposite side in this triangle that we have here, okay? This is our triangle, and y is the opposite side. 6 is the adjacent side. R is our hypotenuse. So our sine of this angle, let's call it sine theta. This is y over r. And our y happens to be a negative. So -8 over 10. There. So this is our sine of theta. And so sine of theta can be reduced to lowest term. That would be -4/5, yes, by 2 and by 2. So that becomes 4 and 5, yes. So it's a negative sine function at the third quadrant, okay? All right, so this is our answer. Let's confirm and verify. All right, so there. So that's -4/5. That goes to our number 9. Let's continue with number 10. All right, let's clear the screen. And let's continue with number 10. Okay, here's number 10. Another diagram. Use the given point on the terminal side of angle theta to find the value of the trigonometric function. We're after cotangent theta. Cotangent theta does not require the hypotenuse. Okay, all right. We shall just draw our reference triangle, okay, at the fourth quadrant. So if we shall draw our reference triangle, it will be like this. Okay. All right. It will be something like this. All right. And then this is our right angle. Our y value. Our y value must be the -18. There. Our x value, of course, will be the +9. And we're looking for cotangent of theta. Where's our theta first? All right, that's our reference angle over here. That's our reference angle over here, okay? The angle made by the x-axis, which is supposed to be this, okay? And the r, okay? The terminal side, this one, okay? All right, so that will be our reference angle. So where's that angle? It's this angle here, okay? All right, and so if we're after cotangent of theta, it will have to be adjacent divided by the opposite side. Adjacent here is the x. and the y is our opposite side. So our cotangent will have to be x over y. Okay, so cotangent of theta will have to be x over y. Like that's our formula. Now tangent of theta will be opposite over adjacent. That's y over x. Now what we have is what uh, we are required to get is cotangent. So it will be the reciprocal x over y. So let's use the numbers. This will be x, which is 9, and y is negative 18. And this is reducible to a lowest term, negative 1/2. So our cotangent of theta is negative 1/2. There. Okay, and that's it. This will be our answer. Let's check there over here. So you can find the answer over here. There. Okay, negative 1/2. Okay, so we're done with number 10. Let's continue with number 11. I hope this number 10 is clear with you. Okay, so just take note of the values and signs of the numbers at the corresponding quadrants. Okay, all right. In the fourth quadrant, the signs for x and y are positive and negative there. That's why we have the values of tangents there and cotangents as well, negative. Okay. All right, so let's continue with number 11. As soon as we clear the screen, let's continue with number 11. Okay, here's number 11. Again, we have an angle at the fourth quadrant. Okay, now cosine function and secant functions are both positive at the fourth quadrant, and the answer here must be positive. Okay, all right, so let's have the reference triangle. The second function will involve the hypotenuse. Okay, this will involve the hypotenuse. So let us have the given and the figure. Okay, this will be our reference triangle. This will be our reference triangle. Our x is positive 4. Our y is the vertical segment, which is negative 2 square root of 5. There. Okay. Now, where's our reference angle? Again, it's the angle made by the terminal side and the horizontal x-axis. So it must be this angle again. There. So again, our y is the opposite, our x is the adjacent. Now for a second function, we need the hypotenuse. So we need the r, okay? We will have to compute for the r. What is r? Okay, again, we'll have to solve it first over here. So r is equal to the square root of the sum of the squares of x and y. There, known as the Pythagorean Theorem formula. So we don't have the r, we will find it. X is 4, so this will be 4 squared. Our y is negative 2 squared of 5. And we will square it. And so we have 16 plus the 2 will become 4, and the square root of 5 when squared is just 5. So 4 times 5, that becomes 20. And this will be r. And so we have a square root of 36. And we have r equal to 6. There. So this must be positive 6. Remember, r is always positive, okay? R. X and y may become positive or negative, okay? All right, but the r is always positive. Okay, so we're after secant of theta, and secant will have the formula r over x, okay? Hypotenuse over adjacent. So our secant of theta will be r over x there. Okay, now we have our r, which is 6, and our x is 4. So reducing the lowest term, this will be 3 halves. And this is our answer. Positive 3 over 2. And this is positive because it's a second function at the fourth quadrant. All right, so let us check and verify. Okay, it's 3 over 2, okay, over here, there. All right, so this must be the right value, secant of angle theta. Let's continue with number 12. Let's have our number 12. Okay, use the given point on the terminal side of angle theta to find the value of the trigonometric function. We're after secant theta again, and the terminal side is located at the first quadrant. There will be no negative numbers there, okay? So we shall determine our reference triangle from the reference angle. This is the reference angle. So this must be our reference triangle. Let's just fix that a little bit. There, all right. So this will now be our reference triangle. Our reference angle will be this, okay? There. And we have a right triangle. There must be a right angle there. And our x, which is 3, take this, will actually be here. Take this side, okay. And then the square root of 7 will be our y, so this will be over here. There. So both numbers are positive, where after the secant function, the secant will involve the hypotenuse r. And it's not there yet. So we will again compute for r, the same formula we had a while ago. And it's this. We shall now substitute x and y in the formula. X is 3. Our y squared will be a square root of 7 squared. So this will give us 9, and square root of 7 when squared is just 7. And we will have r is equal to square root of 16. 9 plus 7 is 16 there. And so square root of 16 is exactly positive 4. Again, r is always positive, so this will have to be a positive 4. And we have completed our reference triangle. We compute for the secant of theta. Okay. Secant of theta formula, this will involve the r divided by x. Okay. This will be our secant theta. All right. So r over x means 4 over 3. There. Okay. This will be 4 over 3. Let's check and verify. Over here is the answer near the diagram by the computer, and that confirms our answer. Number 13 now. Let's continue with number 13. I hope this is clear. Let's continue with 13. All right. Okay, number 13. Let me clear the screen. Continue with 13. All right. We have a terminal side of the second quadrant. Use the given point on the terminal side of angle theta. Our x there is negative square root of 15. Our y is a positive 7. Compute for the cosecant of angle theta. Okay, let us have our reference triangle again. It's the second quadrant this time. So we will try to draw our reference right triangle there. Our reference angle is this. Okay, again, it's the difference between the horizontal x-axis and the terminal side. Okay, the angle made by the terminal side, that's the blue. Okay, that's the blue over here, and the horizontal x-axis. So it's this. Okay, there. That's the reference angle. Okay, all right. So let me clear our diagram so that it will not be messy. All right. So let's put the x and y first. our y is the second number. That's the positive 7. That's our y. There. Okay. Let me clear my equal sign. There. So y is equal to 7. Our x is the first number, negative square root of 15. And that will be for the adjacent side with respect to the reference angle. Okay, that will be for the adjacent side. Now for cosecant function, and yes, cosecant function requires the hypotenuse. Okay, so we will have to compute for the r. Again, the formula for r is the same formula when you have x and y. The Pythagorean theorem formula. And x here is negative square root of 15. But you're going to square it, and y is 7 squared. When you square the square root, okay, it cancels each other. So you will just have here 15. And 7 squared is 49. There. And we have the square root of the sum of 15 and 49. And that looks like 64. So r is square root of 64, which is exactly 8. There. And so our r is 8, positive 8. Let me clear my equal sign. This is 8 there. Okay, we're after cosecant. Cosecant function is the ratio of the hypotenuse to the opposite side, okay, or the reciprocal of sine, okay. So cosecant theta must be r over y, and this will be 8 over 7, okay, 8 over 7. This is our answer. Cosecant theta is 8 over 7. There. It's a positive value at the second quadrant. Okay. So let us check and verify. 8 over 7. There. So 8 over 7 is the answer. Let's continue with number 14. Let's continue with number 14. All right. Let me clear the solutions for number 13 and proceed to number 14. Okay, here's our number 14. Use the given point on the terminal side of angle theta. So again, the function is cosecant, finding the cosecant of the angle theta. So we can draw again our reference triangle. This is our terminal side, and this coincides with the x-axis, and this is our vertical distance to complete the reference right triangle. This is our right angle, and our reference angle will be this angle here, there. Okay, we have the values of the points. We have the values, the coordinates of the point, okay? Coordinates of the point. So our x is the negative 12. Our x is the first number, which is negative 12. And for our reference right triangle, it will be for the adjacent side with respect to this angle, okay? That goes to our adjacent side. Now the 16 is for the vertical distance, okay? That would be for our y. And this is a positive 16 there. Now for a cosecant, again, you'll be needing the hypotenuse r. And that will be to be computed again by the same formula, square root of x squared added to y squared. There. And we can now use the x and y. This is negative 12 squared plus y squared, that'd be 16 squared there, okay? And so r will be square root of 144, that's 12 squared. 16 squared is 256, okay? 256. So how much is this? That will be That exactly is 400. Okay, this looks like a square root of 400, like that. Yes. Okay, so R must be 20. Okay, there. So R is 20. Okay, let me see the ratio. If you divide it by 2, it's a 10. Divide by 2, it's an 8. And that's a 6. Yes, it's correct. That's a positive 20. Okay, now we're ready to compute for our cosecant of theta. Cosecant of theta involves the R ratio to the Y. Okay, there. Okay, all right, that should be for the cosecant of the reference angle. So this will be 20 over 16. This will be 20 over 16, and this is reducible to the lowest term. And this is by 4. 20 by 4 is 5. 16 by 4 is 4. So it must be 5 over 4 for our final answer. And it's a positive value at the second quadrant. Okay. All right, let us check and verify. See the answer near the diagram. There, it's 5 over 4. Right there. And we were able to complete our 14 numbers. I hope you were able to learn from our examples and remember the formulas in finding the 6 trigonometric functions of any angle in a given rectangular coordinate system. All right, so this will be all for now, and see you later. God bless.